Hello, grade 10s. Guys, I want to do this assignment with you. So let's go through your assignment, grade 10s. Let's start with question 1. Let's hear what they are saying about question 1. They are saying in the diagram below, C is a point on the y-axis. Remember, our y-axis is this line here. So they are saying C is a point on the y-axis, which is true. We see C on the y-axis, such that A, B, and D are the vertices of a parallelogram. So we have got A here, this guy here, it's A. So A, B, C, D are the vertices of a parallelogram. So let me indicate this quadrilateral, this shape which is a parallelogram is this shape here. I'm indicating this parallelogram with a blue color. Now, just because we are saying A, B, C, D is a parallelogram, it means that the opposite side, this side is parallel to this side. And this side, it's parallel to this side. So this is one of the property of a parallelogram. Opposite sides of a parallelogram are parallel. Not only parallel, but also equal. So I can say this side of AB, there is A here, there is B here, there is C here, there is D here. So this side of AB, let me just make a one tick, is equals to this side of CD. I'm making one tick. So we are saying these opposite sides of a parallelogram are equal. So I'm going to also say DA, which is opposite to CB. So DA and CB are equal. So opposite sides of a parallelogram are parallel and also equal. So I try to represent the property on the diagram. Okay. Now, okay, whether they say K is a point, okay, and L is a point on AB, such that LK is parallel to CB. They are saying there is a LK here. Let me, LK. Yes, and they are saying this LK is parallel to CB. CB is here. And we know that CB is parallel to AD. Remember this symbol here. I was saying CB is parallel to AD, and they are saying LK is parallel to CB. It means all these lines are parallel. Actually, CB is parallel to LK. It's also parallel to AD. All these three lines are parallel. Okay, now let's read the question. Let's read the question. What does the question say? Calculate the length of a diagonal TB. To calculate the length, we use the distance formula. So the diagonal, they're referring to TB, they're referring to the distance from D to B. This is a diagonal TB. So they want to know the length of a diagonal TB. So we have D here, which is -4 and 2. We have got B here, which is 4 and -4. So now let us find D. Let's say DB equals to, we are looking for the length of a diagonal. So we use the distance formula. We say X at D minus X at B squared plus Y at D minus Y at B squared. So we are looking for the length of DB. We are looking for the distance from D to B by making use of a distance formula. So we say DB equals to the square root of what is x at D? You just come to the coordinates D. What is your x at D? It's minus 5. So you say minus 5 minus, you look for your x at B, which is 4. You go to the point B, you look for the coordinates of x. You see that is 4 there. Squared plus, what is the y at D? Y at D is 2. So y at D is 2. So you say 2 minus, what is y at B? It's minus 4. So you say minus 4 squared. So you say dB equals to, just press your calculator. This is 60. I see 64. I see 36. Square root of 100 is 10. dB is 10. You just press that on your calculator. So we know the length of a diagonal TB. Now they are saying calculate the coordinates of M, the midpoint of DB. Calculate the coordinate of M, the midpoint of DB. So they are saying between the point D and the point B, there is a point exactly in the middle, and that point, it is called M, which is the midpoint. So we need to know, we must know how to find the coordinates of this point, which is at the middle of the point D and the point B. So we're looking for the midpoint. So we must know the x value of the coordinate of M and the y value of the coordinates of M. Remember, the coordinates in mathematics, we have got x and we have got y. And we are saying this coordinates of M is the midpoint of DB. So I have to use the midpoint formula, which is XD plus XB. Because I'm talking about D and B, I'll say XD plus XB over 2. And YD plus YB over 2. You can also say X1 plus X2 over 2, Y1 plus Y2 over 2. So I'm saying XD plus XB over 2. What is X at D? You just go to the point D. X there at D, it's minus 4. Minus 4 plus, you go to the point at B. What is the X at B? It's 4. Here it's X at B. It's 4. This minus 4, it's x at it's y at b. So minus 4 plus 4 over 2 divided by what is y at D? Go to the point D. You see that y there is 2. So you say 2 plus what is y at B? You go to the point B. You look for the y value. It's minus 4 over 2. So press your calculator now. You will get 0. 2 minus 4 is minus 2 and minus 1. So the coordinates of M, the midpoint of DB, it's 0 and negative 1. How do we find the midpoint of 2 points? We use the midpoint formula. Yes, you can say x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we found the coordinates of M. We set it 0 and negative 1. So now we are looking for the gradient of a line AD. Okay, so the gradient of a line AD. How do we find the gradient of a line AD? So the line from A to T, we are looking for the gradient of this line AD. Okay, to find the gradient, you need to use what we call a gradient formula. So you are looking for the small m of AD. The small m represent the gradient. So you're going to say y at D minus y at A over x at D minus x at A. Even if you had said y at a minus y at d over x at a minus x at d, you'll still get the same answer. So what is y at d? You just go to d, y there is 2. What is y at a? You go to a, y there it's 4. What is x at d? Minus 4. What is x at a? 0. So which means that your answer is minus 2 over minus 4, which is 1 over 2. So the gradient of a line AD, it's 1 over 2. How did we find the gradient? Make use of a gradient formula. So we found the gradient of AD. Now on D, they are saying prove that AD is perpendicular to AB. So let me show you AB. So AB is this one. So they are saying, prove that these two lines are perpendicular. Prove that AD is perpendicular to AB. AD, AB. So prove that these two lines are perpendicular. Now, the lines are perpendicular whenever we multiply their gradient should give us -1. So if two lines are perpendicular, if we multiply the gradient of those two lines, we must get -1. So we already know the gradient of AD, it's 1 over 2. So the gradient this side is 1 over 2. We have to find the gradient of AB and check what happens when we take the gradient of AD and multiply it with a gradient of AB. If we get -1, the two lines are perpendicular. So let's find the gradient of AB. M of AB is equals to y at B minus y at A over x at B minus x at A. So you say M of AB equals to, what is y at B? Minus 4. What is y at A? 4. Over, what is x at B? 4. What is x at A? 0. So M of AB, it's minus 8 over 4. And minus 8 over 4, it's minus 2. So we know the gradient of AD, it's 1 over 2. We know the gradient of AB, it's minus 2. So let us multiply the gradient of AD and the gradient of AB and see what happens. So we say M of AD times M of AB. M of AD, it's 1 over 2. M of AB is -2. So what happens? We are getting -1. Therefore, just because when we multiply the gradient of these two lines, we get -1, it means these two lines are perpendicular. So I will say, therefore, AD is perpendicular to AB. Okay, now let me go to E. Determine the equation of KL. The equation of KL in the form y equals to mx plus c. Okay, so I will say, for me to find the equation of a line KL, let me show that line KL with a red color. This is a line KL. There is K here. There is L here. Okay, so I want to know the equation of this line KL. So I need to know the gradient of a line KL. And guess what? I'm not going to calculate the gradient of this line KL because I know that KL, I've been told that KL is parallel to CB. This is what I've been told. KL is parallel to CB. And this CB guy, it is also parallel to AD because they had set A, B, C, D is a parallelogram. So we know that CB is parallel to AD. So all these lines actually, let me identify all these three lines with a red color. CB, KL, AD, they are all parallel. So I will say, okay, KL is also parallel to AD. And we know that lines that are parallel have the same gradient. So we know the gradient of AD, it's 1 over 2. It was calculated. So this means that the gradient of KL also, it's 1 over 2. I will say M of KL, the small m, referring to the gradient, equals to M of AD, reason parallel lines. Parallel lines. Lines that are parallel have the same gradient. Therefore, the gradient of KL is 1 over 2. So I can be able to find the equation of KL because I know the gradient of a line KL. In order to find the equation of a line, you surely need the gradient because you are going to use this formula. You're going to say y equals to mx plus c. We call it the standard form of a straight line. So you say y equals to mx plus c. Y equals to your m, it's 1 over 2. 1 over 2 x plus c. So what is going to be your, you have y equals to 1 over 2 x plus c. So you are almost done finding the equation of a line KL. You just only need to find c now. How can you find c? You go to the line KL, you look for a point on that line. And we do have a point on the line KL, which is point K, which is 0 and negative 2, 1 over 4, which is the same as negative 2 times 4, negative 8 plus 1, negative 7. Is the same as negative 7 over 4. So now I will say, okay, this is my y, this is my x. Now I will say, okay, minus 7 over 4 equals to 1 over 2. My x is 0 plus c. Therefore, minus 7 over 4 equals to c. So now I can give you the equation of a line because I know c now, it's minus 7 over 4. So the equation of a line, you just write this. The equation of a line, it's y equals to 1 over 2x minus 7 over 4. That is the equation of a line KL. Now they say write with reasons the coordinates of C. Okay? Write with reasons. Write down. Actually, they are saying write down with reasons the coordinates of C, meaning we might not even need to calculate. We don't need to calculate. They say you can find the coordinates of C so easy. They are saying you just have to write those coordinates down. Write down the coordinates of C. Okay, at C, I know that the x coordinate at C is 0. That one, I know it. So the x coordinate at C is 0. C is 0 because C is the y-intercept. C is exactly on the y-axis. There is a line of y-axis here. Let me show it with black ink. This is the y-axis. And this is the x-axis. So exactly on the line of y-axis, we know that the x value, it is 0. So we just need to find y. X is 0. How do we find y? Okay, this guy says write down, which means we don't have to make calculations, to be honest. We don't have to calculate. So is there something which I'm missing here? Is there something which I'm missing, or is there any information which I'm missing? Sometimes you have to go back and look at the given information if you feel like there is something that you are missing. In the diagram, C is the point on the y such that A, B, D are the vectors of the A, B, C, D. K is the point, and L is the point on AB such that LK is parallel to CB. I was reading so fast because I was checking if there's anything that I'm missing. Okay, so I'm looking for the coordinates of C. Actually, coordinates of C can be found, but I'm looking for the easier way. So the y coordinate, the x coordinate is 0. How can I find the y coordinate? Is at C. Oh, okay. Oh, this line is perpendicular to this line. But what does he want, this guy? What does he want, this guy? Okay, honestly, guys, I don't see why he says I must just write down. So let me make small calculations. Sometimes you just have to make small calculation. But the way he's asking the question, the solution might be found without even calculating. But what I know is that the gradient of a line BC should be 1 over 2 because it's the same as the gradient of KL is the same as the gradient of AT. So these two lines have the same gradient. So I know that, let me think of it as 0 and y. So I will say if I was to calculate the gradient of BC, I will say minus 4 minus y over minus 4 minus y over 4 minus 0. It must give me 1 over 2. So I'm going to have minus 8 minus 2y after cross multiply equals to 4 minus 2y equals to 12. Divide both sides by minus 2. Y equals to minus 6. So the coordinates of C actually is 0 and minus 6. So I wonder why he's saying just write down this with reasons. I see 0 and negative 6. One of my reasons is that the x value is 0 because C is the y-intercept. That is the reason that I will write. Now, he's also saying the y-coordinate can be found so easily. There might be something which I'm missing. Let's just continue. Let's go to question. No, I can't be on question 4 already. This is question 1, so I need to go to question 2. We need to be on question 2. So let us look at question 2. They are saying KLMN is a rhombus, okay? So a rhombus is a special parallelogram. I will say a rhombus is a special parallelogram, meaning that a rhombus is a parallelogram. So if a rhombus is a parallelogram, it has all properties of a parallelogram. They are saying K, L, M, N, this quadrilateral here is a rhombus. This is a rhombus. So if it is a rhombus, it is also a parallelogram, which means that we know that opposite sides are parallel because a rhombus is a parallelogram. Opposite sides are parallel. And what another thing that we know about a rhombus is that all sides of a rhombus are equal. So this side equals to this side equals to this side equals to this side. That is a rhombus. All sides of a rhombus are equal. So he told me that the angle here is 34. So now he's saying give with reasons for your answer the size of O1. So he's looking for O1. Okay, I will say to you guys, if a shape is a rhombus, the diagonals are perpendicular bisectors. The diagonals of a rhombus are perpendicular bisectors, meaning that the diagonals, they intersect at a point where all those angles at a point is 90 degrees. So O1 is 90. This O4 is 90. O3 is 90. O2 is 90. All angles at a point where the two diagonals of a parallelogram meet, they form 90 degrees. So in a rhombus, we talk about a perpendicular bisector. The diagonals of a rhombus, diagonals of a rhombus are perpendicular bisector of each other. Meaning that where the two diagonals meet, they meet at a point where all those angles is 90 degrees. So O1 is 90 degrees. You say O1 equals to 90, you give a reason. Diagonals are perpendicular bisectors of each other. Okay? Diagonals are perpendicular bisector. So now let me look for the next question, which is the size of L1. So they are looking for the size of L1. It's going to be easy now to find the size of L1, and I'm going to move on that one so quick. Sorry for that, but I think you'll be able to grasp it. I know that O1 is 90. I said O1 is 90, and this K is 34. It means that these angles, let me show you this triangle here. It means L1 plus O1, which is 90, plus K2, which is 34. All these angles in this triangle must add to 180 degrees. The sum of angles in a triangle add to 180. So I will say this guy here, which is 34, plus this guy here, which is 90, plus this guy here, who is L1, must give us 180. Now you solve for L1. You say L1 equals to, all these angles must give us 180. 34 plus 90 plus L1 must give us 180. So you say 180 minus 90 minus 34. I believe L1 is 56. Confirm it with your calculator. Okay, L1 is 56. Now you say the size of K and M. So he's looking for N in triangle K and M. N in triangle K and M. Let me erase so fast. He's looking for angle N in triangle K and M. So he's looking for this N in triangle K and M. So let me do this and this. So he's looking for this angle, which is N1 plus N2. He's looking for angle N in triangle K and M. So what can be this angle? Okay, I found that O1 is 90. I found that L1 is 56. Okay, so what can be this? K and M. What is it that I'm missing? I might be missing something. Okay, I need to check carefully. Can I find L2? If I can find L2, actually, I found K and M. Can I find L2? What's happening? What's happening, sir? Let me check. Let me check. Just bear with me when I'm checking the information. Oh, wait a minute. Yes, this is not being informed. There is one of the property of a parallel of a rhombus which I'm missing actually. It means that the diagonals of a rhombus, they bisect the angles, which means that this should be a property for sure. And I think I recall it. It's not easy to remember all the properties, but here I know that NL seems to be bisecting the angle L. So L2 appears to be 56 as well. So let me confirm. Oh yes. You know how I noticed this? I did not recall that the property that say the diagonal of a rhombus bisect the angles. The diagonals bisect the angles. I did not recall this property, but I recalled some properties that tells me that L2 is 56. How so? Let me show you what came to my mind. Okay, I know that the angle L1 is 56, and I know that this line is parallel to this line. Okay, which means that if I create a line from L to N, this line is actually called a transversal. Now, if you check, the angle L1 and the angle N2 are equal. If you look at the shape which are formed, it's a Z shape. Whenever you are given parallel lines, you look for the Z shape. And those angles that form Z shape are equal. So L1 and N2 are equal. So I know that N2 is 56. Okay, now I go to this triangle. Let me focus on this triangle here, LMN. This triangle here, okay? I know that this guy equals to this guy. Remember, I said all sides of a parallelogram are equal. All these guys are equal, but I want to focus on LM and NM. So LM and NM are equal. Now, if you are given a triangle with two sides that are equal, that triangle, we call it an isosceles triangle. Now, angles that are opposite to those sides, which angle is opposite to the side NM? Is this angle L2. And which angle is opposite to the side LM? Is this angle N2. So these angles which are opposite to equal sides are also equal. It means L2 also, it's 56. So I saw where L1 is 56 and L2 is 56. Now I noticed that I forgot a property that say the diagonal of a rhombus bisect the angle. So this angle here, just because this is a rhombus, okay, just because this is a rhombus, this angle L, it is bisected by this diagonal, meaning that it is divided equally by the diagonal NL. So if L1 is 56, it means L2 is 56. So this is how I will solve this question. Let's go back to the problem. They are looking for the size of K and M. They are looking for this angle here. They're actually looking for this angle here. For sure, you might be confused because I'm talking about angles L1, L2, which are not even these angles here, N1 and N2. But don't worry, if we find L1 and L2, we automatically find this angle K and M, which is the sum of N1 plus N2. Okay, so I will say L1 equals to L2 and say Kamkarachona, all of them equals to 56. I will say diagonal bisect the angle. So the diagonals bisect the angles. So I know what L1 must be equals to L2, which means that the angle L1 plus L2, which is this angle now, the whole angle here is going to be 112. It means the angle KLM, this I'm just saying, look at the triangle KLM and look for L. You'll see what it's L1 plus L2. This KLM, it's 112. And then because this KLM is 112, I will say therefore, or I will just say, let me not say therefore. Let me say this KLM is equals to K and M I have to give a reason why I'm saying this angle here, L1 plus L2, these two angles equal. This guy this side and this guy this side. Why am I saying these angles are equal? Because these are the opposite angles of a rhombus. So opposite angles of a rhombus are equal. So you say opposite angles of a rhombus. Remember, actually a rhombus is a parallelogram, and opposite angles of a parallelogram are equal. So then this angle K and M is also 112. It's 112. Okay, so let's look at the next question. Okay, we are moving. We are going to question 3. We are going to question 3. I want to finish this assignment with a reasonable time. I don't want you to spend too much time. I just want you to work through your solution, your assignment as fast as possible as you can. So I don't want to spend too much time explaining a lot of things. If you keep visiting my channel, I will explain some stuff. For now, I want you guys to be ready for your assignment, but make sure that you study it. ABCD is a parallelogram with AD being parallel to BC. So AD is parallel to BC and AB parallel to DC. AB parallel to DC. So if it is a parallelogram, the opposite sides are equal. It means AD is equals to BC. That's what we know about a parallelogram. Opposite sides of a parallelogram are equal. And also AB is equals to CD. Okay, and another thing that we know about a parallelogram is that opposite angles, if you look at the angle T here, it must be equals to the angle B. Opposite angles are equal. And also the angle A here must be equals to the angle C. So opposite angles of a parallelogram are equal. So they say, give us the size of ABD in terms of X. ABD. A, B, D. So they're looking for angle B in triangle ABT. So they are looking for this angle here. I'm highlighting the angle with a blank in color. Yes, this B in triangle ABT. And guess what? This angle B, it's 3x. Why? Whenever you are given two lines that are parallel, let us focus on the line AB. Let us focus on the line AB, which is parallel to the line CT. And then create a line which touch these two parallel lines. We call it a transversal line. So this guy is parallel to this guy. So this, look, we have got a Z shape. So if this angle here it's 3x, it means this angle here it's 3x. So you say, write ABD in terms of x. You now say A, B, G is equals to 3x. What is the reason? The angles that form a Z shape, they are called alternate angles. You say this ABT is equals to CDB, which is 3x. The reason is alternate angles. Alternate angles. Alternate angles are equal, and then you specify the parallel line you have used. You know that AB is parallel to CT. So this angle here is 3x. Okay. Yes. Yes. Okay, this angle here also it is 2x if you were to use this other Z shape, but you were not asked that. You were not asked to find this angle, but it's 2x just because this line is parallel to this line. So Z shape there. Okay, calculate the value of x. They want me to find the magnitude of x, the size of the angle x. How do I do that? How do I find the size of x? Okay, he gave me this angle which is 75. Okay, how can I want to find a simpler way of solving the problem. He gave me this one, it say it's 75. And he said I should find this angle here. I found it being 3x. Okay, so it's easy actually to find x because I will focus on a triangle A, B, O. I will focus on this triangle A, B, O. And I will say all these angles in a triangle add to 180. So I will say 3x plus 4x plus 75 equals to 180. Don't forget to write the reason. Sum of angles in a triangle. If you add all angles in a triangle, you must get 180 degrees. So you are now going to say 7x is equals to what? You take 75 to the other side. So you say 180 minus 75, which I believe is 105. So you now divide both sides by x. I mean by 7, sorry. X is equals to 105 over 7. I don't think 7 can go into 105. I don't think 105 is divisible by 7. You just put it into decimal form, press it on your calculator and see what happens. You say 105 divided by 7. That is the value of x. Now you are going to, if x is 15, calculate the magnitude of BCD. Maybe 105 divided by 7 is 15. Is it? 15 times 7, is it 105? I'm just curious. Let me just check. 15 times 7, which is the same as 15 times 10 minus 3, which is 150 minus 45. Oh, yes. It's 15. It's 15. Okay, 105 divided by 7 is 15. So what is he saying? Let me go back to the question. If x equals to 15, find the magnitude of BCD. Give us the size of the angle C in triangle BCD. He says BCD. So he's looking for angle C in triangle BCD. Angle C. Let's go to the triangle B. Let me erase all this other stuff. So it is B, C, D. So he's looking for this angle actually here. He's looking for this angle here. The magnitude of this angle. Okay, how do we find the magnitude of this angle? So here, this one I've noticed, remember I said this one it's 3x. Okay. So what is this angle A in terms of x? The whole angle A, if you are focusing on a triangle ABD, watch out. The examiner is asking about the angle C, but I'm focusing on angle A. Why am I doing this? Because I know that angle A and angle C are equal. So if I can find angle A, I found angle C. Why am I saying they are equal? These two angles that are opposite are equal. Opposite angles of a parallelogram are equal. If a quadrilateral is a parallelogram, opposite angles are equal. So if I find A, I found C. So I know that A actually, this A, it's 180 minus 5x. sum of angles in a triangle. So you say 180 minus 5x, and we are told that x is 15. So you say 180 minus 5 times 15. This is angle A, and whatever you find after saying 180 minus 5 times 15, just press your calculator and say 180 minus 5 times 15. Whatever you get here is also C. But you must tell us that A is equals to C. You say opposite angles of a parallelogram. In geometry, it's very important to provide reasons. So let's go to question 4. Okay, question 4. Question 4, it contains one of the theorem I love, which is called a midpoint theorem. I think I should explain the theorem before we continue. Let's say we have a triangle ABC, A, B, C. And we notice that a line which intersect A, which touch A, let me create a line which come and touch, I mean the side AB, and also touch the side AC. Now, if this line divide the side AB equally, maybe we say, let me say this is M, and you find where MA it's 5 and MB it's 5, and it goes and do the same thing. The line go and do the same this side. We find maybe 4 this side and 4 this side. So we say, oh, here we can talk about the midpoint theorem. The midpoint theorem. If there is a line that divides two sides of a triangle equally, then we use what we call a midpoint theorem. Let me do this. This is a triangle. So if there is a line that which connects these two other sides like this, and it divides this side equally, and this other side also equally, then we talk about the midpoint theorem. So in a midpoint theorem, we are going to say, this means that the line BC, automatically when you see the midpoint theorem, you say the line BC, it is parallel to the line ME. I'm here now. And you also say the BC, it is twice the ME. Okay? I've explained midpoint theorem. It will make things easier when we are solving the length of GF on question 4. So let me try to increase. Yes. Let me decrease a bit because I need the information. Yes. So let me erase. Okay. I do. What's happening? Okay, sorry guys. Sorry for that. Okay, let's look. We are looking for the length of GF, but let's read the information. It's saying the distance from A to F is 10 centimeter. Okay, so distance from A to F is 10 centimeter, and it's saying AD equals to DB. AD equals to DB. Okay, and it's saying CF equals to FE equals to BEB. So I will just focus for now, I'll focus on FE equals to EB. I will say FE equals to EB. So you can see that actually this is a midpoint theorem because this line divides these sides of a triangle equally. AD equals to DB, and here FE equals to EB. So we talk about the midpoint theorem. And I said, okay, so it means that AF is parallel to DE according to the midpoint theorem, and also AF, which is the longer compared to DE, relative to DE. We say AF equals to 2DE, which means that AF, since it's 10, DE is going to be 5. So DE is 5. Okay, they are looking for GF, but we are busy finding sites such as DE, but you'll see how this will help us. Now let's go to this triangle. Now let's put our focus on this triangle. Okay, so we were told actually that CF equals to FE. So I will erase all this other stuff so that you can see where I'm putting my focus. We were told that CF equals to FE. So CF equals to FE. And we also noticed that actually we from the midpoint theorem, we have noticed that the line DE, this line, is parallel to GF. Remember, I said it here. I said AF here. I said AF is parallel to DE. The line of AF, DF. AF, the line of AF is also the line of GF. So the GF is parallel to DE. So because GF is parallel to DE and CF is also equals to FE, we can apply again the midpoint theorem. So I will say DE, it is twice GF. So DE, remember DE, we said it's 5. 5 equals to 2GF. Then we divide both sides by 2. Therefore, GF equals to 5 over 2. I believe it's 2,5. Yes, I think I rushed this problem through, but please try, go and check some midpoint theorem and try to understand what I've just done here. Okay, finally, question 5 is the last question of your assignment. Okay, so they are saying, the question says, prove that triangle ABE, so let us check ABE, ABE, this triangle ABE, it's congruent to the triangle CDF, CDF. Okay, reading of the information is important. In the diagram below, ABCD is a parallelogram. So if ABCD is a parallelogram, we know that opposite sides are equal. So we know that AB is equals to CD and AD is equals to BC. So AB equals to CD. Opposite sides of a parallelogram are equal. So this will help us when we prove that ABE is congruent to CDF. And another thing that you have to identify about the triangle ABE and the triangle CDF is that both of these two triangles are right angle triangles. So I will say we can talk about hypotenuse angle theorem of proving that two triangles are congruent. I will say, look, AB, which is the hypotenuse of the triangle ABE, is equals to CD, which is the hypotenuse of a triangle CDF, the right angle triangle CDF, AB, CD. So these hypotenuses are equal. Why are they equal? Actually, this comes from the definition of a parallelogram. Opposite, okay, let me just say opposite sides of a parallelogram are equal. So we see that these two triangles, their hypotenuse are equal. So what we need now to bring forth now is the angle. So if we have got the hypotenuses that are equal, and we have the angles from those two triangles that are equal, then those two triangles are congruent. So let's check angles that are equal. I want us to focus on A1 and C2. I will say A1 and C2 are equal. Let me show you. This Z shape worked a lot of time in this assignment of yours. So you need to know the alternate angles. You should be able to see alternate angles. We said this line AB is parallel to CD. Remember the shape ABCD is a parallelogram. So opposite sides are parallel. Now let me create a transversal which touch these two parallel lines, which means that A1 and C2 are equal. I'm hoping that you see a Z shape here. Okay, A1 equals to C2. You must tell us why are they equal. These are the alternate angles. Make sure that you check the correct definition of the alternate. These are the alternate angles. Then you specify parallel lines. AB is parallel to CD. When you give us alternate angles, specify parallel lines. Then therefore, the triangle ABE is congruent to the triangle CDF by what we call hypotenuse angle theorem of a right angle triangle. Okay, so we have proven that the two triangles are congruent. I want to highlight those two triangles, which is the triangle ABE and the triangle CDF. Now, triangles that are congruent, they have corresponding sides that are equal. So this means that once we have triangles that are congruent, remember we have proven that these two triangles are congruent. It means that this side, actually we already know that is equals to this side, opposite side of a parallelogram, which now the side AE is going to be equals to FC. And then the side BE is equals to FD. Okay, just because these triangles have been proven to be congruent. So once the triangles are congruent, we know that their corresponding sides are equal. So in this case, I will say BE correspond with DF. So those corresponding sides are equal. AE correspond with CF. Those corresponding sides are equal. Okay, now let's go to last question, which says prove that BEDF is a parallelogram. So let us look at the shape BEDF. BEDF is this shape, BEDF. So they are saying we must prove that is a parallelogram. Okay, so we know that opposite sides of a parallelogram are equal. So they are saying prove that BEDF is a parallelogram. So if it's a parallelogram, BE, the side BE must be equals to the side DF. And already we know that BE equals to DF. So you say BE equals to DF. Why? This comes from the fact that the triangle BABE is congruent to the triangle CDF. So you actually just say corresponding sides of congruent triangles. These are the corresponding sides of congruent triangles. So these two sides, BE and TF, are equal. So now I already know that BE equals to TF. If I can prove that BE is also parallel to DF, remember opposite sides of a parallelogram are not only equal, they are equal and also parallel. So I've already shown that BE equals to DF. What I have to show is that BE is also parallel to DF. If I can show that BE is parallel to DF, then the shape becomes a parallelogram. So how can I prove that BE is parallel to DF? Let me erase. So I want to prove that BE is parallel to DF. I want to show that the line BE is parallel to the line TF. And then, okay, I want to have this line here, which is my possible transversal. So for the line BE to be parallel to TF, I know that the angle E2 must be equals to the angle F2. So if these two angles are equal, then BE is going to be parallel to FT, or you can say TF. Okay, so how can I prove that E2 equals to F2? Simple. You say E1 plus E2, it's 180. These are the angles on a straight line. E1 and E2, they are on a straight line. Angle on a straight line at to 180. So we already know E1 is 90. So you say 90 plus E2 equals to 180. E2 equals to 90. So what about F2? We know that F1 plus F2, it's 180, still angles on a straight line. We know F1 is 90, so 90 plus F2 equals to 180, F2 equals to 90. So E2 equals to 90, F2 equals to 90, therefore BE is parallel to FT. Look at E2 and F2. They appear to be alternate. They appear to be forming a Z shape. Just because those angles which appear to be alternate are equal, it means the line BE is parallel to DF. So I will say since E2 is equals to F2, BE is parallel to FD, you say converse of alternate angles. Those angles appear to be alternate. Check the correct spelling of alternate. Converse of alternate angle. So now because BE is parallel to FD and BE is also equals to FD, then BEDF is a parallelogram. Okay, let me give you a quadrilateral. I think I'm done. I'm just wrapping up. Let me give you a quadrilateral. If I give you a quadrilateral and I say to you, these two opposite sides, I want to focus on these two opposite sides. I say the AB is parallel to CD. And I also come again and say AB is equals to CD. Automatically, ABDC becomes a parallelogram. Thank you, grade 10s. It was great dealing with your assignment. Hopefully, You will remain on my YouTube channel. I will keep posting some videos specifically for grade 10. So keep and come and observe on my YouTube channel. Thank you so much. God bless you and keep you safe. That's where we end.